Hello everyone, welcome to this session. In this session, we will talk about the GA stopping criterion, and at last, we will provide a summary to GA. As we can see from the workflow of GA, we have covered the initialization, selection, crossover, and mutation. So replacement is very straightforward. Now we leave the last block, termination conditions, or we call it the stopping criterion or stopping conditions. That is the same thing. So this is why we are trying to answer when will we stop the GA iterations? Because if the stopping criterion is not met, GA will continue to produce new generations, right? So we need to stop GA at a proper time. So there are several kinds of stopping conditions. Let me introduce. There are major three of them. First of all, we may set the maximum number of iterations or generations. So we say, okay, the GA run 1,000 generations and finish. So this is mainly decided by the computing budget, right, or the patience of the user. The second is that when there is a satisfactory solution is obtained, we stop the GA. So for example, the optimization problem, we just want to satisfy some constraint. So when the constraint is satisfied, the performance is okay, then we stop GA. We no need to optimize anymore. And the third is that the population converges. So this means that the population clusters to one point and its neighbor. So in this way, when we continue doing GA, we can't expect much improvement. So in this case, the GA can be stopped. So in the real practice, we may use one or multiple of these stopping criteria. So this we will cover it in the advanced specialization, not in this fundamental specialization. Now we can give a summary of the GA, of the evolution mechanism, right? So evolution mechanism, there include crossover and mutation and selection. So they are different. Here we make the comparison. For crossover and mutation, we use them to increase the population diversity, right? So to generate new candidates. And they have nothing to do with fitness. The goal of the crossover and mutation, they focus on generating new individuals, right? Well, selection, this is quite different. Selection decreases the population diversity, and the fitness increases. The selection we focus on makes the population enter in the promising areas. So we iteratively do these two processes. Get optimal, the promising areas, then we crossover mutation. We generate better things in this area. Then we select the promising area again. We go back to crossover mutation to generate new things in this new promising area. So that's why the evolutionary algorithm can continuously generate better and better solutions, right? So eventually we can summarize the advantages and drawbacks of GAs. Let's first see the advantages. First of all, GA is a general optimization method, independent of the problem domain. So the problem we have introduced before, for example, the TSP, QAP, right? And the lifecycle problem, the antenna design problem, those problems can all be solved by GA. So it's a general method. Also, because of the use of population, the candidate solutions, the evaluation of them does not depend on each other. So therefore, they can be evaluated in parallel. Also, because of using a population, we are able to generate various kinds of optimal solutions for the user to select. And also, the GA implementation process is not difficult, and there are even more easier ways. And I will discuss in the later sessions about how to use MATLAB built-in GA functions to implement GA. Right? Although GA have these advantages, there are also disadvantages. First of all, the GA may not obtain a very high-quality optimal solution. It may obtain an optimal solution, satisfactory, but sometimes it's not very high quality. Yeah, so we still need some other method to support it. Second, the GA has several parameters. So for example, the population size, right? The crossover rate, so those kinds of things, right? So the selection of these parameters affects the quality of the solution. So this we need to pay more attention to, and we will also cover this in the advanced specialization. At last, GA is not very fast, so it needs a lot of computing power, right? Although the parallel computing can indeed support it. Okay, that's all for the GA. And this is the end of the session. So thank you for listening. Bye-bye.